Hi guys, one of your classmates was asking me about vertical and horizontal stretching and compressing, and so I thought I'd just make this little mini tutorial video or a little mini lesson video about that subject. And yeah, if you guys are having issues with a certain topic, then let me know. I can make these kind of things as long as it's not as long as I don't have too many to do, as long as I have time. I've sent individual homework solution guides as well. So if that's also an issue, if you're stuck in a problem, feel free to ask. Okay, anyways, here we go. So mini lesson on graphing, stretching, compressing. I think vertical to me, I think is not too hard. So this is just kind of recap. I know we covered this subject already in the section, but I just wanted to reiterate a couple things. In particular, to me, horizontal I think is more confusing. So vertical though, first of all, it comes from this form when you're multiplying by some number before your f of x. And just as an easy example, let's pick an easy number. Let's just say 3. Okay, so you have y equals to 3 f of x as an example. This is going to be a stretch by 3. And then we'll also do a compression. So for compression, for vertical, it's a fraction. So something like a third would be a compression. Anything that's less than 1 is a compression. Okay, so what happens is when you're doing a vertical compression, I always think of it as like, okay, let's say you go out to the right by 1, and then you go up by 1. Well, if you're stretching by 3, then this becomes, you still go out by the same value, but you're vertically stretching. So, oops, there you go. So instead of going up by 1, you're going to go up by 3 instead. So that's the idea of the stretch, right? And then now, if you're compressing, let's say I go out by 1 and I go up by 1. Oh, I spelled instead wrong, sorry. Okay, instead of doing that, if you have a compression, you're going to still go up by the same amount, but you're going to go up by a third of that, right? So instead of going up by 1, you go up by 1/3. Stick to the same color scheme. So let's see an example of that in action. And this one, whatever value it is, you're just going to keep that constant. The same left and right movement as you have, you're going to keep that the same as it originally was. And you just multiply the up and down movement by whatever the new value is. So let's look at an easy example. Let me think of a good one. I'm trying to think of an example where you don't go out 1 and up 1, because I feel like a lot of our graphs are like that. Like if I think about absolute value of x, when I graph that thing from the center, you go out 1 and up 1, right? From the starting position. Or if I think about something like x squared, you go out 1, you go up 1, right? Or if I think about x cubed, same thing. You go out 1 and up 1. So a lot of these graphs for that first initial point, they follow that pattern of out 1, up 1. But if we go 2 out, then you'll see a little difference. So let's just pick x cubed as an example, okay? So where does the multiplier happen? The multiplier happens after this function is already taking place, right? After the cubing has already happened, if it's a vertical stretch. So an example for the vertical stretch would be 3x cubed. Okay, so what would happen? In a normal graph for 3x cubed, you'd have, okay, here's your graph. You'd have the origin as a point, right? 0, 0. And normally, if I go out by 1, I go up by 1. And let's do 2 as well. If I go up by 2, 2 cubed would be 8. 2, 3, 4, 5, 6, 7, 8. Up here. So you have this point, right? I just realized it's not going to fit here nicely. So let me make more space. I'm trying to think. How do I want to do this? Let's do it like this. No. I want to go in the middle. Okay, let's get rid of the horizontal thing for now. Okay, so you start from the center, right? That's the point. And then out 1, let's make these ticks small. Out 1, up 1 would be another point. And left 1, down would be another point. This is the original graph. And then when if you got 2, you go up 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And if you go left 2, then you're down 8. 1, 2, 3, 4, 5, 6, 7, 8. So normally x cubed graph, you've got all these points, and then you'd connect it something like this, right? This would be y equals to x cubed, the original. Okay, so all stretching does is it's gonna stretch vertically. If it's multiplying by 3 in the front, then instead of going out 1, up 1, you're gonna still go out 1, but you're gonna go up by 3. And left 1, down 1, you're gonna change it to left 1, down 3. 1, 2, 3. So this would be the new point. Left 1, down 3, right 1, up 3. You can even label this points 1, comma 3. This would be -1, -3. Okay, normally when you go 2 from the center, you go up 8, right? But we're going by 3 times that, so we're going to go up by, instead of 8, we're going to go up by 8 times 3, which is 24. So that's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. So somewhere over here. So you're out 2 and up 24 instead of out 2 and up 8. So now I'm going through these red points, something like that. And the graph's not totally perfect because I'm kind of squished in, but that's the principle. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So over here somewhere. Right, so that's a vertical stretch. Okay, on the other hand, let's say you had something like y equals to 1/3 x cubed. Okay, whereas normally you go out 1, up 1, now you're going to go out 1, up 1/3 of that. So out 1, up 1/3, it's like over here. And left 1 and down 1/3, it's like over here. I don't know if you guys can see this. It's really tiny. I made my tick small so I could fit 24. Okay, normally you go out 2 by, and then up 20, out 2, up 8 is the original, right? But now I'm going to go out 2, up 8/3. 8 divided by 3, or 1/3 times 8. And 8/3, that's 2 and 2/3. Okay, so out 2, up 1, 2 and 2/3. So over here. So if it's a horizontal, a vertical compression, then it looks something like that, right? So those would be your values. Left 2/3, something like this. Okay. So you can even label those points. You'd have this guy, sorry. This guy over here, the origin is the same. That guy over here would be out 1 and up by 1/3 now. And then over here, second point would be out 2 and up by 8/3, or 2 and 2/3. And then same idea on the other side. This one would be -1 and then now -1/3. And a little lower here, you'd have -2 and -8/3. Yes, that's the idea. Okay, that's vertical stretching and compressing. Okay, let's move on to the horizontal one. I think horizontal one is the more interesting one, the one that we're likely to have more issues with. Horizontal stretching and compressing. So for this guy, the form is something like this: f of ax, or I think they use b instead, but it doesn't matter. Just some constant, something that you're multiplying by. This is the general form. F of bx. I forget what letters. I think it was b. Yeah? The letter is not so important as just the fact that this is some placeholder for a number, a constant number that doesn't change. Okay, so let's use a simple example. Wait, what did I do last time? Yeah, I did 3. Okay, so let's do 3. So notice this time the 3 is inside the parentheses, and that's what makes it a horizontal stretch as opposed to a vertical one. Or you could do f of 1/3. And when I say stretch, I actually mean it could be a compression. So this one's actually the compression. This one is the stretch. Let's do them one at a time, though. All right, let's start with the graph. So we're going to do, as an example, just like we did last time, x cubed. All right, let's do this thing, sketch this thing out. And, another recommendation I have, I forget if I mentioned this in a different video, but try fooling around with the Desmos graphing calculator and just change things around, change the parameters, and see how the graph shifts up or down or stretches or whatever, moves up, moves left, reflects, all that stuff. Okay, so here the original graph where you go out one and up one, and the center is the center still, right? This is the original graph. Out one, up one, left one, down one. And then you go out two, up eight. 1, 2, 3, 4, 5, 6, 7, 8. And left two, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Like this, yeah? Okay, this is the original graph. This is just regular old x cubed. Okay, so how does it change now if I have y is equal to, and now pay attention to where this 3 happens here, guys. It's not 3x cubed. It's 3x, and then that thing is cubed. So the function really is the cubing, and then this 3 is the horizontal stretch part of that. Or horizontal compression in this case. And let's change the color here. So inside the parentheses, basically, yeah? Inside the parentheses means it's going to be a horizontal change. And now, okay, here's the thing. Normally, when I was doing the vertical one, I go out to the left or right, and then I go up or down, right? But if I'm going to do a horizontal stretch, I'm going to actually think of it in the reverse. I think of it as I'm going up one and then right one. That's the normal, yeah? So in this case, if it's multiplied by 3, remember, horizontal is actually, you do the opposite. So multiplying by 3 is actually a 1/3 compression. So if it's horizontal, you take the reciprocal. Instead of 3, it's 1/3 compression. So that means normally I go up 1, out 1, but this time I'm going to go up 1 and out by just 1/3. So I'm going to get this point here, right here. What is that point? That's the up is the 1 and out is just 1/3. And similarly, normally I go down 1, left 1, and notice I go down first because this is a horizontal thing I'm changing. The down part is still down 1, but I'm going left by 1/3 instead. So this is the new point right there. It's down by 1, so that's the y coordinate, and then left by 1/3, so negative 1/3. So negative 1/3 comma negative 1 and 1/3 comma 1, those are the new points. And then normally you go up 8, I think of it as up now, up 8 and 2 to the right, right? That's where this point is. But I'm not doing that. I'm gonna go up 8 still, but I'm gonna go 2 times 1/3. 2 times 1/3 is 2/3. So up 8, but out only by 2/3. 2/3 is not even it's not even 1 yet. I'm over here. So here, this is the new one. See how it's compressed inwards to the left and right? It's compressed horizontally. This point is gonna be what did I just say? So you're up by 8, right? And then horizontally, you're only to the right by 2/3. And then similarly, you got 2/3 and negative 8. So over here, like this. What's that point? That's negative 8. Sorry, wrong one. The negative 8 is the y coordinate. And then the x coordinate is negative 2/3. So you're only going to the left by 2/3 instead of going to the left by normally would be 2, right? Okay, this graph is getting a little messy, so let's make a new copy here for the horizontal stretching. Horizontal stretching is a little easier to see. And it'll be easier once I have its own graph here. So here I'm going to graph two things. I'm going to graph the original function, x cubed. And then in blue, we'll do y is equal to, this is 1/3 x. That whole thing cubed. And notice again, the 1/3 is being applied before the function transformation is, no, not transformation, that's not the right word. Before the function of cubing is applied. Before the f of x is applied. So, original graph first. Center, you get the center, right? Out 1, up 1. And out left, down 1. And then out 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And down 8. 1, 2, 3, 4, 5, 6, 7, 8. So you have these points here, right? This is the original. Okay, now we're gonna do this guy. So remember, horizontal, it's the reciprocal. So if this number is 1/3, that means we're going to do a stretch. This is a horizontal stretch by 3. You flip this guy upside down, right? Okay, what does that mean? Normally, I go up 1 and right 1, right? But now, I'm gonna go up 1 and right 3. And normally I go down 1 and left 1, but now I'm gonna go down 1 and left 3. So this point is gonna be, okay, let's do the vertical. The vertical went up 1, but horizontally I went over 3. This one, vertically I went down 1, but horizontally I went left by 3. You see the difference? So now it's like this, like that, and it's gonna connect somewhere after that. Okay, well, let's do the next point. Okay, so normally I would go up by 8, right, over here, and then I'd only go over by 2. But instead of going over by 2, now I'm gonna go by 2, stretch that by 3. So 2 times 3 is 6. 1, 2, 3, 4, 5, 6. So now this point is gonna move out to this position. Oops, I don't want to keep those there. And then this point also is gonna move out by up to 6, right? 1, 2, 3, 3 more. That's negative 6. Right, the original position would, if you look at, I'm sorry, this original point, it was what was it? 2,8. Right, but now I'm gonna multiply this 2 by 6. It's a move of 6 instead of by 2. So that gives me this point 6,8. And this one would be the same thing but negative. So negative 6, negative 8. Now let's connect those dots. Look something like this. Yeah, and you see how this blue graph is really just the original graph, but stretched out left and right, stretched out horizontally. Right, so that's how I deal with horizontal and vertical stretches, and how we do. And from now on, all of us are gonna do it something like this, I think. Or if you have some other way that works, then that's good too.